Can you not hear me? Well, we're having all kinds of technical problems this morning. Yeah, between the tweets going out at the wrong time this morning and now the audio issues, but I think I have it finally all straightened out. Uh, we'll give it just a second, and hopefully everybody can hear me then. Yeah, okay. Sorry about that. Wow, that's about the way my week is going. So apologize for that, but I think we're good now. So I'll recap where I was, which was to do just a little bit of news before we jump into our main topic. And the main news that I wanted to tell everyone about was the fact that the HANA trial on the SAP Cloud platform is now fully available. As of Sunday, the missing entitlements are added, and the ones that you want are to be able to do development, you need the SAP HANA schemas and HDI containers as well. And if you set up a new trial account at this point, you'll get it automatically. But if you have an existing trial, you can just come in here and do add service plans and search for HANA. And you'll see the HANA schemas and HDI containers. Not the trial one. Not to be confused, because there is one that says trial, and you might think, oh, I'm in the cloud platform trial. That's the one I should be using. No, actually, that's for the older HANA as a service trial. And if you use that one accidentally, you'll be directed not to the HANA Cloud, but the older HANA as a service. So what you want to do is go ahead and add the plans for the SAP HANA schemas and HDI containers. And if you want, you can then delete the entitlements for the HANA schemas and HDI containers trial, or leave them. But on my account, I actually deleted the entitlements so I don't accidentally use them. It does have a different service name, but still it can get a little confusing if you aren't careful. Now, that's actually what tomorrow's special episode will all be about, a special 30-minute episode where I'll show you how to set up your HANA Cloud trial, how to enable the entitlements as we saw here, how to set up the Business Application Studio, how to do your first bit of development in the HANA Cloud trial and deploy a CAP application to it, and how to use the Database Explorer and Cloud Cockpit. Looking forward to doing that special episode tomorrow. Kind of squeezed it into the schedule at the last minute because we were waiting for this fix to come in, and it just came in on Sunday, so I threw that into the schedule there. All right. So with the news out of the way and our technical difficulties hopefully all taken care of now, what I want to talk to you about today is actually comes from a request from the community. If you watch the show regularly, you know that a couple weeks ago I asked I showed a new code sample for HANA and CAP that we've been working on, and I asked for community suggestions. And I've gotten a fair number of community suggestions out here, some of which we've already done, and some of which we're still working on. I know Rich was just working on the SQL script stuff the other day. But the one that I pulled out for this week was one not so much that I want to add to this sample, but one that I thought was a really interesting topic to talk about in general, which was the subject of TypeScript. TypeScript for your Node.js modules when you're doing cloud native development or XSA development, and how it might or might not relate to CAP development specifically. So that's what I've prepared for today. And as we're going to go ahead and do this right now, let's just go ahead and close this issue, and I'll add a link to the show in there afterwards. But so that's good. And I think it's really neat that we're able to get these suggestions from the community, and we're still welcome to take more suggestions, trying to be transparent here as to, as we're working on them, we're using a project board to show the progress of the ones that we're addressing. So I think this is a good use of the community interaction and the tooling that goes along that most open source projects use. I don't see why we can't use that for some of these sample projects that we do as well. But let's talk about TypeScript now. And what I've got here, let's just put these things side by side a little bit here. I've prepared some samples because honestly, we'll back up for a second. Maybe people that aren't familiar with TypeScript in general, talk about it just a little bit. The idea, well, of JavaScript is that it's not typed. Meaning you don't have to declare the data types for your variables and objects and other such things. That allows a lot of flexibility, so I can have a function and I don't have to declare the interface of the function. I can pass all different kinds of things into it. The first time I call it, I can send it an integer in the first input parameter. I can send it a string the next time, and there will be no check at well, there is no compile time with JavaScript, right? Even at runtime, there would be no type checks. It would allow that. So JavaScript is that gives it somewhat its very lightweight nature. The fact that you don't have to declare the types and interfaces and things like that. It kind of brings in the concepts of like overloading functions very naturally, because you can just, by what you pass in, change the input parameters, adapt them, and certain frameworks like CAP utilize this quite heavily to be able to pass, entity objects without having to define them in the language, define them as strictly typed, and so it has its pros in that, as I said, it's very lightweight, and for frameworks that deal with very dynamic objects, very dynamic interfaces, this can be very much a positive. But the downside is it can lead to unwanted errors. It can lead to you accidentally passing a string when the receiving logic is really expecting it to be an integer. And even if the receiving code does some sort of checks, you can do checks at runtime. You can check the type of on a variable. There's no design time checks. There's no compile time checks. There's no compile time in JavaScript at all. And it also leads to the fact that editors and IDEs in general have a hard time providing you much support in the environment. They can't, you don't get as much, say, code completion, or, I can't mouse over a function and see the declaration of the function, the interface definition, because it isn't accessible until runtime. So it's a real trade-off here of the lightweight nature and being able to quickly get started with things in the language, but losing some of those conveniences later on. Now, what TypeScript does is it attempts to bring that strongly typed concepts to the JavaScript world, and it's sort of a variant of the language. It's mostly JavaScript. There's some TypeScript specific language constructs, or maybe you call it a subset of JavaScript, or depending on how you look at it, maybe a superscript, a superset of the language, because sometimes it allows you to implement things that aren't natively implemented in the underlying JavaScript. We'll see that in a minute here. But it attempts to somewhat abstract the JavaScript language, or at least the versions and the differences in the language, but provide the strongly typed nature that you might be used to from other languages. And I see Lars commenting that it's great for ABAP developers, and that's what I thought initially as well, that this should feel right at home for ABAP developers, because we're used to ABAP being such a strongly typed language, right? So the other thing it brings a lot of convenience features into the development environment, a development environment that is intelligent enough to be able to read and understand TypeScript. And we'll see that here in a minute as well, as we start doing a little bit of development also. And how this works is you need a TypeScript compiler. So what you would do first is, and I'm just going to reuse as we go along here. I had to go learn this myself. I had never done a whole lot of TypeScript before this weekend because I'll have to admit, to me, yes, I have a background in ABAP development, and once I got into it, the typing felt very natural. But at the same time, as somebody who's done JavaScript as sort of a separate fork in their career from many early days in the starting in web development, it felt a little unnatural to declare these types, and it felt a little bit like, oh, are we trying to take JavaScript and turn it into something that it shouldn't be? It felt like inherently this went against the very nature of what JavaScript is. So I kind of personally always stayed away from it. It was like aware of it on the periphery, but I had never really played with it until I was forced to, for the show, to kind of say, well, let's sit down and let's learn this. But I have to say, I started with just some of the basic tutorials from Microsoft's TypeScriptLanguage.org site, and was pretty impressed. There's some good getting started information here, and let's just run through a couple of the basics, and we'll talk about what's going on here. So first of all, you want to install, and I did globally as well. Just do an npm install TypeScript, and that puts the tsc command globally into your environment. And what you see here is we have the ability. This is a tool. The main thing that you'll use the TSC tool is to compile or transcode the TypeScript code into regular JavaScript. And that's really the secret of what's going on here. Is in TypeScript, we'll get design time type checks, but then we'll run this TSC command, and it will compile the TypeScript code to plain JavaScript. And at runtime, you're still going to have regular JavaScript without the type checks and things like that, but it will inject code in to maybe enforce some of those things. And of course, the compiler will enforce things as well. It will enforce your types and perform these checks for you. So we get this extra layer of design time that you would not normally have with JavaScript, but you do get this extra step to perform this build. And as DJ said, it is kind of the best of both worlds in that regard, because at design time you get what you want, which is a lot of safety checking, type checking, IDE support, but you're not really giving up too much at runtime, particularly as we'll see here, if you target, and you can target different versions of ECMA, different versions of JavaScript. This is also a nice feature of TypeScript, is it lets you code in one TypeScript language and then be able to support maybe even older versions of JavaScript, and it will perform workarounds for newer JavaScript syntax that maybe isn't available in older versions of ECMA. For instance, the whole promises async await, that wasn't introduced until ES 2017, if I remember right. And if you then want to target, because of maybe your browser support or something like that, if you were doing front-end development, maybe you need to target ES5 or something like that, it will still allow you to do async await, but it will inject its own JavaScript code and custom functions to provide the same sort of functionality. But it's very nice because you can have one TypeScript-based code base, but then target potentially different versions of JavaScript at runtime. So that is where you get. I think you do get some nice benefits of both worlds there. Let's see. Yeah, let's go ahead and just do one of these basic tutorials real quick here. And I've got a bunch of. I'm going to do this cooking show style as I often do, where I have some examples already prepared, and others we'll do completely from scratch here, mainly to avoid having you guys watch me do just too much typing. But if I come here and let's do basics 3. So got an empty folder in a project here, and we can just go to this basics3. We'll go in that. And what we can do here is actually this first example is a little too basic. We'll kind of mix some stuff in, but what you can do here, what I usually do when I start a new project, do a tsc init, and what that does is that creates this tsconfig JSON file for you, and fills in all the possible options and a few defaults. And as you see here, these are basically the compiler settings that will be used by your project then. And this allows you to do things like I was talking about, like target different versions of ECMA, target different ways to do module support, target there's all different kinds of settings where you can set your input and output options. Like, we're going to keep this really basic here, but I'll show you some better structured projects here in a second, where maybe we want to have a separate source and distribution folder. So our Typescript files are separated from our JS files, so when we compile them, they go into different folders. Much later, you'll see when I started using this in CAP, I customized this for the CAP folder structure, where it expects to find its like exit handlers, so that when it compiles the TypeScript, it puts the JavaScript in a place that CAP expects to find it. So there's a lot of control that you have over how this compilation process happens. But let's go ahead. Let's just follow along here with the tutorial, and what we can do is we'll go ahead and we'll just create a new TypeScript file. We'll keep this very simple. What do they call this? Reader.ts. And see, habit. I put a .js on the end just by habit. I can't help it. Let's go ahead and put this in. Now this isn't terribly well typed, is it? But that's the point. And since we're not doing this on the front end, we're doing this from the console. We're going to test. We'll just put this reader, and I have a hard time typing var too these days. There we are. And what we can see here is that already I have a squiggly here telling me that something's not right. I didn't type the interface. I just put person, which means it's going to default to a type any, and that inherently, although technically allowed, and one of the things that you can turn on with your tsconfig or with your JSLint, you can alter this to say, yes, I do allow any, but it really doesn't like anything that's implicitly typed, because to its defense, it's like, well, then why use TypeScript if you aren't going to type things? But what I want to show you is, even though I haven't taken advantage of the typing here, you can see I am getting, like, I can see the signature greeter person. It expects an interface of person and of type any. And if I do something here like this and put in another, then you see expected 1 arguments but got 2. So it's telling me I'm doing some stupid stuff here based upon what I've declared. But if I go ahead and I say TSC, even though this is an error, I'll go ahead and say greeter, and it will compile that. And it goes ahead and creates it, but actually it didn't. I didn't save that. Well, that's a rookie mistake, isn't it? Now that I've saved it, let's try that again. And I will point out, TSC also has a watch command, very similar to like the CDS watch, so that as you're editing files, it will automatically recompile. I'm not a big fan of those watch commands where things automatically happen as you type. that bothers me when I'm trying to work and I see stuff going on in the console. That's purely personal preference. I know some people really like those features, but I'm going to do everything kind of manually here. But what you see is, yes, it compiled, and yes, I got errors. I got compilation errors, but it went ahead and created the JavaScript file anyway. This I thought was an interesting aspect of TypeScript. It will yell at you, it will give you errors, and then it will go ahead and say, okay, you're stupid. I know it, you know it, but I'm going to go ahead and do it anyway, and go ahead and give you your JavaScript output. And I actually kind of like that because then I can see sometimes, maybe what's going on there and why, what happened. But you see, it still produced perfectly fine JavaScript because ultimately what it creates is JavaScript untyped, and we can even now run this if I just say node reader.js. Still runs. Doesn't blow up at runtime because ultimately it's still JavaScript at runtime and allows you to do stupid things with the types and pass extra parameters into a function that weren't declared. So ultimately this is still JavaScript, right? But let's go ahead and fix this stuff. So let's put a type on this. So you just put colon and then put your type. I'm just going to say I'm expecting a string here, and I'll fix this dumb extra thing. And now I don't have errors anymore. If I look at my greeter, now the signature says greeter person string, so it's expecting a string. That's very nice. Like if I think yeah, get nice code completion here. It's a little off my editor, but let's put that back. And just show you it's all checked out now. Let's go ahead and compile that again. And ultimately, the output looks the same, other than the fact that I changed and I don't pass in that one extra variable. It doesn't have any impact on the runtime, but now I have a complete cleaner compile time, and I have better, certainly a better design time editor experience by declaring those types in advance. So let me look over the chat real quick. I see it's been going pretty good, but I don't know if that's people chatting about other stuff. Timely stream about TypeScript. I mostly avoid TypeScript in favor of using later ECMA features, classes, optional chaining, which largely later versions of Node support. No need for transpiling code. That's true. I mean, some of those later features there, but ultimately, type checking on basic things, just basic variables and functions like that, you either end up having to provide extra code to do that. Plus, you don't get the editor support that I don't think with many of those other features, to quite to the level that you might with TypeScript. But yeah. But getting started to recently VS Code extensions. That's the default language in VS Code extensions. Interesting topic because I've been learning VS Code extensions myself lately, and I was actually doing it in non-TypeScript. But you're right. The default in most of the tutorials and things like that all show TypeScript. Yeah, looks like there's a little other discussion. But yeah, I think we can move on at this point. So I went through this, like I said, the TypeScriptLanguage.org had a good example here. I went through a couple of different examples that they had. There's another good article here on how to interact with modules that we'll look at in a second. I'm just pointing out a few of the resources that I went through to really learn this. But let's show you some of the other examples here that I had already prepared with project structures that are a little bit more robust, if you will. So first of all, we have here, let's see, in this example, this is a pretty this is the basic example once again, but the only difference here is I wanted to structure my project a little cleaner. If you look at this basics 3, we're dumping our TS files into the root, and then we're compiling them, and the JS files go into the same target folder. That's okay if you're just doing a little learning project, but if you're going to structure a real project, you probably want to separate things out a little bit more. And almost all the samples that I found seem to follow a pattern where they create an SRC or source folder, and that's where they put their TypeScript files, and then they have a separate dist or distribution folder, and that's where they put their target compiled JavaScript. And all you have to do to set up that kind of situation, and I'm a little surprised, like the init, and maybe there's a flag on the init that will set it up this way, because this seems to be so common in all the samples and stuff that I looked at. But you just need to alter your out directory, and that will control where the compiled JavaScript files go to. And then I told it. Yeah, I think that was all I had to do, because it would scan and find the JS automatically. I don't think I had to. You can change the base URL and root dirs if you want. There's also source root and map root. There's lots of different options. I use that in some of the later examples. But to get this sort of structure, starting from the root with a source, all I had to do was add this output dist. So then I was able to take, and here, this is basically the same example, function hello, and we have a string, and we're setting it to a default value if nothing is passed in. We're saying the result of the function is a string as well, so we've typed our function, both the input and the output in this case, and then return hello world. We can see that here. Now, when I mouse over, I can see my input is expecting word. The little question mark at the end of the parameter tells you that it is an optional parameter, and that the string at the end tells us the function is expecting to return a string as well. So this is even more fully typed than my previous little example that I put together. And of course, if we were to run this, even if because it's an optional parameter, let's go ahead and take out passing word in there. We don't need to do that because we have it here as a default. And if we go into basics, and we do a TSC, and that compiled, and sort of rewrote our JavaScript. And what you see here is this is a little bit more going on here. You know, where our other example was essentially the same code, what we see here, and actually we can get rid of that for now, give me a little bit more space to work with, is it's now having to do, because in older versions of JavaScript, we didn't have the default parameter values. So what it's having to do is it's having to see if word wasn't passed in, then to set that value automatically. Now, what might be interesting, I'm trying to remember what ES version that we got that functionality to have default values on parameters, but maybe we'll just play around with this in a second. But if I go ahead and run this, dist index, then we see it still outputs hello. Well, we were getting fancy here. I'm putting an icon, and of course in the console it can't output that. But yeah, we see it working. Now what might be interesting here, let's play around with this. Let's just experiment for a second. Instead of ES5, I can't remember. Let's start with ES 2017. So we're changing the target version of JavaScript that we want to compile to. And this is part of the beauty of TypeScript as well. Now let's compile that again. And now what we see is now that has changed, because now we're targeting a newer version of JavaScript, which has the feature to allow default parameter values inherently in JavaScript. So it doesn't need to insert its own little hack code workaround for the older versions of JavaScript. This is one of the benefits of TypeScript if you do have to target older versions of JavaScript for some reason, is it can give you access to some of the newer syntax and constructs in JavaScript, even when your target version, the target runtime version of JavaScript doesn't support it yet. So this can be a very nice feature if you don't know what maybe you don't know what version of JavaScript is going to run on. You have to sort of code for a lowest common denominator. This can give you a lot of flexibility, but keep in mind that some of these workarounds are maybe not as performant as just being able to target the native constructs in JavaScript directly. It's injecting extra code to be able to do some of these things. All right, so I'm going to check the chat again real quick. I wonder, suppose we have a Git repo, what would we store, the TS files, or supposed to run JavaScript files, or both? I see it's hard to tell from the samples. I don't know what the best practice there is as far as pushing. I would, I don't know, I'm a little torn on that. I mean, I do a lot of samples, so I like pushing the results, but I guess in theory, you wouldn't, in other situations where you compile or transpile anything, you don't normally send like the output, the distribution folder, to Git. So one could assume that you would add a git ignore to block any folder with dist, and then not send the .js. And then of course when somebody did pulled your package down, you'd have to make sure that like a post install in your package JSON did the TSC to build that, very similar to the way that say cap does, where you usually trigger that on a post install. But I don't know, I'm not sure what the best practice is in the TypeScript community. Kind of being a newbie here myself, maybe there's an overriding feeling there in general. Quick summary for Tom next time he looks at the chat, which is now. DJ is trying to wind people up by expressing a dislike for class-based OO. That's about it. All right, thanks DJ for summarizing your chat, and have at it there. Let's see, I'll just scan here real quick to see if there's other questions. TypeScript autocomplete is awesome, though. Yes, I agree. One of the major reasons why I would consider the extra overhead of doing TypeScript is exactly for the autocomplete and the other IDE features. A very big plus. Someone says, save your TypeScript on the repo. JS files become part of the install and build. That was my feeling as well, as I said, but interesting to see what the community overall says. It's good to provide your input there. That's great. I see another person saying the same thing. Yeah, so my instinct seems to be on the right track there. Been doing VS Code extensions as well, and could agree with you and Oliver on that. Yep. Maybe we'll do some future stuff on VS Code extensions. I've been playing around with it to learn it myself and having great fun with it. Saw a great YouTube video where someone was writing a reduced polyfill for i6 the other day. Wonderful. Okay, that sounds painful. Thomas, the console result is behind your chair. Oh, it is a little bit behind my chair, isn't it? Sorry about that. Thanks for pointing that out. I hope it isn't too cut off. You can see most of it, but I'll tell you what, I'll move that over a little bit, so as we move forward, it will work a little bit better. Fetches the JS and associated DTS files. Yeah, okay. Sounds like we're pretty caught up there. Hopefully everybody's still with us here. I know this is a little bit of a deep dive, but let's look at a couple other examples that I have prepared. I went through a couple other tutorials here. The basics too is kind of just more of the same, just different scenarios here. I was testing out different constructs, and I'm not going to go through all of these here right now. I did, and an interface is kind of just preparing me for the more complex things that I wanted to do, building up to eventually getting to cap, and that's where we want to get here in the show. So let me skip the rest of the basics, and let me instead show you where I went next with my experimentation, which was, let's start with Express. Let's wrap Express and use it in TypeScript. I thought that would be a good one to start with. One, because I could find plenty of examples of how to do that. Express is so widely used in JavaScript, I figured there had to be some good tutorials exactly on how to do this with Express. And sure enough, and I'll put all these links in the description of the show afterwards. But I found a really nice tutorial here, specifically, which one is it? I found one specific. Yeah, here it is. Specifically on how to use Node.js Express from TypeScript. It really answered a lot of my questions about how to reuse an existing module that was not itself written in TypeScript. And what it turns out is that the community has basically built types for a lot of these common modules. So what you can do here is my main dependencies in my package JSON, I've got reference to Express. But then my dev dependencies, there's this @types namespace where the community or the original authors of a module can submit types for their non-TypeScript written modules. And that allows us to kind of retrofit and get access to the types for an existing module without that module having to be rewritten in TypeScript. So in this case, I also got the types for Node.js itself, the Node.js core runtime. That's another one of these central types that are available. And I added in the TypeScript runtime itself. And if we look at then the index TS, this is pretty simple. Now I do this import Express from Express, and what it knows to do is it's pulling the import not from the Node.js module from the TypeScript side. Is if you look at it here, it's going into Node modules @types Express. So it automatically first tries to look it knows about this @types namespace, the tooling itself, the TypeScript IDE, and it knows to go look there automatically. It's looking there first to see if there is a type definition, an index type definition. And sure enough, if we were to go look in our Node modules and we look at types, and then we would look at Express, there's an index.d.ts that has been contributed that builds just the types for the standard Express module. Okay? And it will use that in my importing of the TS instead, importing of Express instead in my TypeScript file. And now I can do things like I can see the types on Express. But more interestingly, I thought, as I do like the get command, I can mouse over it and I can see the parameters that are possible. I like that instead of having to maybe go check the documentation. But Express is still pretty complex because it has multiple overloads and it's very dynamic. But as you see here, I can do things like my request. I expect a request and a response, and I've typed those as well. I use the Express, and then it's got, and you can refer to the existing types from that import just by a dot and the name of the type. So now, for instance, like the request send or the response, I can see the possible functions that I can call, and on the send, I can see the interface. It's very nice. It's much more robust, obviously, than just having to go and look stuff up in the documentation, which is what we often have to do in JavaScript, right? And we can see that we're sending a body of type any. A lot of these, when you are working with modules that are not written in TypeScript, you get a lot of any's, you get a lot of objects, so it's not very strictly typed, but it still allows you to get some IDE support if nothing else, and avoids maybe errors like what I'm about to commit right here, which is sending extra parameters that the function isn't even designed to support. But it still wouldn't do like a strict type check. If I would pass something incompatible here, it won't stop me. I won't check that because that's a type any. But we see it's pretty easy, even if you have an existing module that isn't written in TypeScript, to be able to work with it. Let me check the chat real quick. Okay, we seem to be doing okay there. And we're all building up here to cap. But the next place I wanted to go before I went to cap is I wanted to go to one of my own modules that I've written. So I have a module, this HANA HDB-EXT-promisfied example. And actually, let me bring that up over here in another window. So what I wanted to do, this is obviously, the module is not written in TypeScript, but, oops. But what I wanted to do is, what I've done to this module, and I just published this the other day, is I went ahead, I didn't rewrite it in TypeScript, but I added an @types folder. And inside there's an index.d.ts where I have defined types for the class that I'm exposing in this module. And a lot of them, likewise, because this is mainly a wrapper around the HANA client, and it's very dynamic. You see a lot of the types are object, are returning a promise of an object. This is a nice example to show you how you can declare that I want to return a promise, and that promise has a particular type expected. You just put that in the brackets at the end of the promise. So you see how you can do this with an existing JavaScript library. Not too great here, but I am at least like on schema procedure. I'm telling it's a string, so if you pass an integer, but likewise, you're now gonna get IDE support, like the code completion or in the IDE, you're going to get checking of the proper number of parameters and things like that, even if it is a lot of objects and sort of still semi-generically typed, it's better than nothing. But I've added this to the sample, and I published this to npm. So if you use the HDB-EXT-promisfied wrapper from npm, then in your TypeScript project, now you can just, you'll pull those types automatically. So if we look at this example, and I look at the index.ts, what you see here is I'm importing from the module SAP HDB EXT promisfied, which it finds it from the module, but now my types are embedded in that module. One of the other options that we have to distribute types, the original author of the library can distribute types in their module directly. And what we see here is then basically the same code that you would use to call this. I'm just creating a connection to the database, creating a prepared statement, then executing that prepared statement. But now, once again, I can see the parameters of the expected interfaces in the IDE. I get checks, for instance, if I add an extra parameter here that isn't allowed or isn't expected, it will catch that, which is good. Or if I would do something weird here, like, all right, so now I'm passing too many arguments, but also my type on that first argument is wrong. If I take that out, then I think you'll see that, yeah, it's going to say argument of type 1 is not assignable to parameter string. So we're getting some at least simplistic type checking, but that's all good as well. And just to show you here the output on this one. Now notice what I want to show you is my tsconfig. I'm targeting ES6. ES6 does not actually have await, async await in it, but I use that JavaScript syntax here in TypeScript. But if I look at my compiled You had to write a whole bunch of extra stuff basically to emulate async await, really. Wow, that's a lot of code and not super simple to read, but it worked around the fact that that basically we don't have that async await functionality yet, and use this this yield functionality and all this extra coding here, return an awaiter to emulate the async await functionality in older versions of JavaScript. We could, of course, if we do want to target, though, we could just change the tsconfig from ES6 to ES17 or later, and then it would generate JavaScript code that looked very much like the TypeScript. You would use the native async await and wouldn't have all that extra JavaScript in it. Okay? And that brings us to the last example, the one that I really wanted to get to today, the original request, which was how to do this with cap. So I've created another example here, just a simple cap project, nothing to write home about. Basically, I went and stole the simple bookshop example, which just has books and authors and genres. And if we look at the SRV and we look at cat CDS, we're just exposing catalog service with books. All right, that's all we're really interested in here. And like I said, I just cut and pasted this right from the samples on SAP samples for the Cap Cloud project in Node.js, the most simple bookshop example. But what I was interested in is I wanted to start off. I wanted to do an exit, a handler, an event handler, and I wanted to do it in TypeScript. So following the same concepts of what we've done here, if I look in my source folder, I've got a little cat service TypeScript that I'm going to want to compile into the SRV folder that then can be linked as the handler for my cap project. Now, the first thing I needed to do is cap doesn't come with any of the types or interfaces, so I started declaring them myself. And what you see here is I have one entity, books, so I exported an interface type for that entity and just matched it up pretty much to the CDS definition of that entity. I wanted then to supply some types for the CDS event handler itself. And in order to do that, it would kind of work backwards here. Basically, when you do a this, I wanted to do a this after. So what I needed to do is, by default, that uses the built-in node module type. And what I was able to do is just say export an interface that extends node module. So I'm building on top of the sort of generic node module interface. And I add whatever event handlers that I want to use in my code. I'm only using the after event, but if I was using others, the before or on, I would declare those here as well. And then I have to declare the expected interface. So I went and looked at the CAP documentation and said, okay, well, it expects an event, and then an entity, and then the handler. And then it returns a void. It returns nothing. So let me declare those. I could have just put these at any, or generically type them, but I wanted to even further type into the interface here. So for event, I went and created an enum for the possible events that can be passed in. For the entity, I said, well, it expects a string, but I created an enum for the possible entities that are used in my project, just to make it a little cleaner. And then for my event handler to respond to this event, well, we get the request object, right? We get the data, which is type any, nothing we can do about that, but we get a request object. So I went and I looked in the documentation of CAP once again to see how the request object was structured. So I put a little interface in here for it as well. And a lot of this is still generically typed. You see a lot of objects and any's and stuff like that. But once again, this is going to give us access, at least in the IDE, to help us with these things. Now, the coding is not all that different than what you would expect. Now, the only thing I had to do is I had to take the normal this object, which would be generically typed, and I cast it. That's what I'm doing here. I'm basically saying take this and put it into my own variable, underscore this, but cast it through this type that I declared up here, which was the inherited type from node module. And that way, I've got a this after that the cap runtime will automatically be calling, but now it is Typescript, and you can see that here in the editor. I'm getting things like checking of the types, the parameters are coming in. I'm using my enums instead of hard coding the values, in my function interface, and now even things like I'm saying, well, I expect to get this data as type any, but I'm going to cast it into my books type because that's my entity here. And now when I do things like I come here and I say each, I can see all the parameters of my entity in my editor. So I get, once again, I get the better type checking of my code and the better editor support even in CDS. Now, good point here, DJ. We need a CDS compile to TypeScript. And I thought, well, wouldn't that be cool if we had that? We could really use that. But as it turns out, someone in the community has kind of already done that. Let me just show you that real quick. This is a blog from not too long ago. I missed it when it first came out, I have to admit. But taking CAP to the next level with TypeScript, they've done a community project that is a compiler that will compile your CDS to TypeScript. And then also they make it easier to add the routing, basically all the stuff that I had to declare to create an interface for my route handler. They've created a generic CDS route handler that you can use here as well. And I use this. I brought the module down. Let's see. Come here to my package JSON, you see that my dev dependencies, I just included the CDS2 types, and then from the command line I could use the CDS2 types and pointed it to my schema, and it generated in the entities folder this index.ts, which is basically my TypeScript interface for the complete CDS model. So I wouldn't have needed to do all that typing. I mean, it was good for me from an educational standpoint to know how to do it by hand, but the community has wonderfully already created a project that does the work for you. And then the other example here where I use their functionality, I'm just going to use their CDS routing handlers here. And I don't need to declare the types and hooks for the handler. I can just say an after read and then add my own public function there to work on that. So, depending on what you want to do here, if you want to build it yourself by hand and quickly inject it into CDS, I got a little example here of how you can do it. But the community has built a really nice reusable framework here to both generate the types and then hook them into the routing. So I know this was a bit of a roundabout way to get to this. I could have just started, I guess, would have been a very short episode and said, hey, the community's taking care of this for you, have at it. But I thought it was really worthwhile to go through the whole process, particularly maybe those of you that maybe haven't played with TypeScript before, maybe kind of turned their nose up at it as I had somewhat in the past, to give you an introduction to TypeScript. Hopefully you understand a little bit more the value proposition of it and where it might be used, how to integrate it with existing modules that are not themselves written in TypeScript, and then very specifically, in this case, the great functionality that we have to use this along with CAP CDS as well. So with that summary, I hope everybody has enjoyed this episode. A deep dive on the world of TypeScript, certainly. As I said, join us again tomorrow for a special extra episode of the About Free Show, where we will take a 30-minute look at developing on the new HANA Cloud trial. So until then, just 24 hours from now, thanks for joining us. I hope you enjoyed the show, and join us again tomorrow for that special episode. Thanks.